Hi there, Uri. So in this video for this lesson, we're going to be looking at how to divide terms. So in our previous video, I talk about how to multiply terms and the things that you had to look out for. So there's that video link up here. We're now currently looking at the next two examples where we had simplify something that looks like a fraction, which is a division of terms. So here we've got divisions on these two sides as well. So let's have a look at C and D together. How would I do C and how would I do D? Okay, so C wants you to simplify 10 times AB all over 15 times BC. Notice the language I'm using. I'm saying 18 over here times x squared y over 8 times xy. Okay, because what I want you to remember is that between each and every one of these letters and numbers, you're actually multiplying each term. That's what you're doing there. It's just that we're too lazy to write the times symbol. It's actually 10 times A. Now, even though when we say AB, it actually means A times B as well. So you've got these three numbers multiplying to each other. And the reason why I want to highlight that to you is because in fractions, we know that, say, I'll give you an example on the side here. When we have 1 over 2 times 3 over 4, how do you multiply in fractions again? You would do top with top, bottom and bottom, right? So in this case, you would actually be writing 1 times 3 over 2 times 4 when you start to simplify it, meaning you collect them together. Now, similarly, if you currently have 10 times A over, say, B, and this is 15, what I want you to see is when you collect it together, you would say top with top, so it'll be 10 times A over bottom with bottom, and that will be 15 times B. But remember, we are lazy with writing the multiplication symbol. So in fact, it would end up being 10A over 15B. So you can see the problem that we currently have is a collected term, or it's one collected fraction. So 10A over 15B is actually the same thing as splitting up the fraction as 10 over 15 times A over B. That's another way of looking at it. So when I split this fraction up over here, if I want to work with it, I can actually write it as 10 over 15 times A over B times B over C. You see that? Now, the reason why I want to do that is because by separating the terms, it's actually easier to divide. So let's have a look here. Can we see that when we do multiplication, okay, multiplication, we know that the order doesn't matter. So on the top, you would normally do 10 times the A and then whatever that is times the B, right? But it doesn't actually matter about the order. You can actually write it as 10 times times B times A if you wanted to. Okay, so it means you can swap the positioning if you'd like. Now that only works for multiplication and addition. It doesn't work with subtraction and division. Okay, so over here, what I'm going to do is, my tip for you is I would keep the numbers with the numbers and letters with the letters. The letters that look alike, I'll keep them together. So what I'm going to do is I'm going to write 10 over 15. Those are numbers. I still have the times, but instead of A over B, I'm going to switch the A position and the B position because I know it won't affect the overall answer. So it now becomes B divided by B times, and I've got A over C. Okay, can you see that? So what I've done there is I've taken this first question in red, 10AB over 15BC, and I've broken it down into three separate fractions. Now I can take my time to do what I've learned back in fractions in term 2 to try to simplify the fractions here. See, here we've got 10 over 15. We know what factor can go into 15 and 10. We know that 5 is a common factor, or the highest common factor. So 10 over 15 is the same thing as writing 5 goes into 10 2 times and 5 goes into 15 3 times. So here I have 2 over 3 simplified. Okay, so 10 over 15 is the same thing as 2/3 times. Now this is where I want to train you all to understand. b over b, what's your common factor? What does that equal to? What does b divided by b become? And it actually is 1. Okay? And the reason why b divided by b is equal to 1, well, another way of thinking about it is they both have a common factor of b. True? So because they both have a common b term, then b goes into b once. Okay, or if you're getting confused by what I'm saying there, if I asked you, what is 3 divided by 3? Hopefully, if you ever think about it or use a calculator, it should equal to 1, because 3 fits into 3 once. If I asked you what 4 divided by 4 is, you should see the pattern is 4 fits into 4 once. So when I say, what is 1,000,000 divided by 1,000,000, it should still be 1, because 1,000,000 fits into 1,000,000 only once. So that means when you start to work with letters or pronumerals or variables, b divided by b is also equal to 1. Remember, b is just a number. We just don't know what that number is. But whatever that number is, it clearly will fit itself once. Okay, so that's the reasoning behind it. So going back here, we know that b goes into b once and b goes into b once. So you can think of it as it's 1 divided by 1, which is 1. And then times over here, well, I don't know what a is and I don't know what c is. So I'm just going to leave it as it is. So here, can you see by breaking it apart, I've simplified some of the terms that I knew. And now when you multiply fractions, what do? It's top with top and then bottom with bottom. So if you write it all together again, you collapse it, it's 2 times 1 times a over 3 times 1 times c, and your final answer here is now 2 times 1 times a just becomes 2a because we're lazy to write the time symbol. And then 3 times 1 is 3, but 3 times c is 3c. Okay, so that's how you would do that particular problem when you're breaking it apart. Okay, so that's my tip for you is I would like you to practice breaking it apart first. And then in my next example, I'm going to try to show you a shorter technique than this. Okay, I'll show you a shorter technique so that way you can do it, but I want you to understand it first, because if you try the shorter technique, you're more likely to make a mistake if you didn't understand how you can break these terms apart. Okay, so let's have a look. What's a shorter technique to doing this? Now, when I was in high school back then, this is what I was doing in my mind. So we've got 18 over 8, we've got x squared, we've got x on the bottom, and this is y, and this is y, right? Back in high school, the way I did it, or the way my teachers taught me, was that you look at the numbers and you say, well, there's an 18 divided by 8. What's a common factor that goes into both of them? And we can say that, well, we know that 2, this is where your times tables come in. 2 goes into 8 4 times, and 2 goes into 18 9 times. All right, so we cross simplify that. And then we also know that you can do y divided by y. We know that y divided by y cancels out to be 1. Most students don't write 1. I actually write it in for my students to see. So y divided by y is 1. And then this is where it's interesting. X squared divided by x. When I was in high school, the way my teachers taught me is they said, when there's this square there, so when you divide by x, this cancels out and you cancel out the 1 up there. So 1 away from the 2, now you're left with x to the power of 1. So your final answer after going through all that is 9x 1y1 all over 4, and that's it. Okay, and you don't need to write the 1s up there, I'm just writing it. And that's how students would have done it back then. But you see, that shows a lot of there's a lot of shortcuts here, and a lot of students who don't really understand how to cross simplify will make mistakes as they go to the higher levels. So I would generally not encourage you to do this unless you understand how this works. So I'm going to show you what we were doing in between. Okay, so let's see if you understand why this breaks down to the way it does. Here we go. So we have 18 x squared y. Remember, in between them, we're actually multiplying them, aren't we? We're multiplying them. We can split the fraction up. That was y, this was x, and this was 8. Now we understand why 18 over 8 simplifies to 9 on 4. This one we know. This one we've been practicing. Okay, so that was okay. That was pretty straightforward. That became 9 over 4 times, and most of you might have just learnt before that y divided by y is the same thing as saying, well, what is itself divided by itself? And we knew the answer had to be 1. Or alternatively, they both have a common factor of y. So y goes in a y once, and y goes in a y again once. So we've got 1 over 1. Okay, so that was pretty straightforward there. We can say that's 1 over 1. But what about x squared over x? Okay, so what does x squared divided by x look like? And this is where, if I break it apart for my students to see, let's take this and just observe it over here. Okay, so let's observe it. X squared divided by x. Why did my teacher say that it is okay to just cancel out the 2 cancel out by 1 because there's only one x below? Okay, if there's 2 x's below, then you cancel out 2 on the top. Why can they teach you that way? Well, x squared, if I ask you, what does x squared mean? Okay, no, it's not 2x. A lot of students think x squared is the same thing as 2 times x. It's not. X squared is x times x, right? And you're now dividing it by x, 1x on the bottom. You see, using fractions, x times x over x, you can actually say, well, I can actually split up the fractions. I can say that's the same thing as x times x on the numerator, so numerator. Denominator, I've got one of these x's here, but then what do I put in this position here? You see, there's only one x, but x times what will equal itself? Well, the answer has to be 1. You see that? If you actually tried combining these two fractions, x times x and x times 1, can you see x times x will give you, I'm going to highlight it, x multiplied to x will give you x squared, and then x times 1 is x. So you can see here why my teacher was saying that if you only had one x on the bottom and you had 2 x's on the top, when you divide them, of course, only one of them is going to cancel out. Only this will cancel out because x divided by x we knew before was 1. So that means you're still left with 1x on this fraction here. So when you combine it together, it becomes 1 times x over, again, 1 times 1. That's why the answer becomes x over 1. Okay, and that's what my teacher was trying to say here. Can you see there was only one x left over in their answer? So the way I like you to understand it is, if you didn't understand the shortcut there, you can work your way through this. It takes a lot more practice with letters and fractions, but you will get so much better and grounded in your foundations. Okay, so here you've got 9 over 4. We just worked out x squared divided by x was x over 1. So here we go. I'm going to write x over 1 times 1 over 1. And you can see here, we simplified all together. Fractions, we would do top with top, bottom with bottom. So if you write that out, that becomes 9 times x times 1 all over 4 times 1 times 1, which we know 9 times x, I don't know, but I do know what 9 times 1 is. That's just 9. But 9 times x, we're too lazy. We just write 9x. And then 4 times 1 times 1, it's just 4. And that's the same answer. Oh, wait, where's my y? Whoops, that means this was wrong. Whoops. There we go. How about that? I made a mistake in the first one. But there you go. So by doing both, you can see that I had already made a mistake before. So there you go. That's how you would do it in a long method. And I do want you to practice it to get your head around this, not to make the mistake of doing that. Okay, so a lot of students aren't sure how to divide x squared over x. And if you understand it, I can show you a few more over here just to get you thinking about it. Here we go. Let's try. If I gave you x to the power of 7 divided by x to the power of 5. Okay, what I want you to understand is x to the power of 7 is the same thing as writing x times x times x times x. That's 4 times already. 5, 6, 7. True? All over x to the power of 5 is x times x times x times x. That's 1, 2, 3, 4, 5. Okay? Now, if we use what we understood just now, we can break the fractions apart. we can break them all individually apart. Okay, and this is where you start to pick up. There are 7 of these x's on the top and there are 5 of these x's on the bottom. What you can already see is when you start simplifying them, x divided by x we know is 1. Multiplied to the next x divided by x is also 1 times, again this is x divided by x is 1 times, again this is another x divided by x which is 1 times, this is again x divided by x which is 1 times, and then now we have just x in the numerator by itself. So what goes in the denominator? It's 1 times, and again we've got another x over here. That's x over 1. Okay, because we don't have any more x's in the denominator. So now, if you think about it, if this all cancels out to be 1, this is 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 1, well then you actually end up being, or having, 1 times 1 itself is just 1. And then times x over 1 times x over 1. Now remember, when you write the number 1 as a fraction, it's the same thing as 1 over 1. And can you see, collecting the fractions together, 1 times x, so top with top, and then bottom with bottom. Can you see, you actually just end up with x times x, which is x squared, over 1 times 1 times 1 is just 1. So the answer is just x squared. And now, what's the shortcut? So this is what that was the long method for you to see it. But you see, there's a pattern here. There are 7 of these x's on the top, and there are 5 of these x's on the bottom. We knew that 5 of them were going to cancel out to be 1. So how many left over? There was only 2. So of course, x times x is x squared. That's the final answer. But that's how we would have learnt it in high school back when I was in high school. My teacher would have said, well, there's 5 here and there's 7 there. You can then cross off the 5. Cross off the 5 up here and you're left with 2. So therefore the answer is x squared. So that's the shortcut, but I don't want you to do that shortcut unless you understand what's actually happening here, because often that's where it starts leading to mistakes, where students just cancel things out without knowing why it works. If you understand how it works, which is this section here, you can only cancel things out when it is x divided by x. The common mistake is when students get something like this in year 12. Okay, so year 11 and 12, students will make the mistake of saying, oh, yep, I've got an x squared, I've got an x, I'm going to cancel out one of them. And you can't do that. Okay, so that one won't work. And in class, I'll show you why that doesn't work. But for today's lesson only, I'm just going to stop there. But that's a common mistake because of this technique that has been taught over and over, where you just simply cancel things out and just write 2. That's the problem, and I don't want you to learn it that way. Okay, so really, I know this looks really messy and tedious, but that's the problem. Students avoid this technique or understanding fractions really well. That's why I'm still fixing the senior students in terms of what their arithmetic skills are. Okay, so try to understand over trying to just complete the task. Okay, so going back to some examples over here, you can pause the video to have a think for a bit, but I'm going to do textbook question 4 as an example to help you if you're watching this video here, just to guide you along. I'm going to show you the long method and the short method as well. Okay, so here we go. A, you have 5a over 10a. The long method is you're going to split it up into 5 over 10 times a over a. We can simplify this now because numerator was 5a means 5 times a, so that's what I've done. I'll split up the fraction, and then 10a just means 10 times a on the denominator. Now we're going to simplify the fraction here. We know that 5 goes into 5 once and 5 goes into 10 twice, so 5 tenths is the same as half, multiplied to a divided by a. Remember, that is equivalent to 1. Okay, and so that gives you the answer of half. So that's how I would want you to practice before trying to do a shortcut, which I'm going to do B. If you're trying to do a shortcut, this is what it may look like. You see, you can understand this as x divided by y you can't do, so the only thing you can do is the 7 and the 14. So 7 goes into 7 once and 7 goes into 14 twice. So your final answer is 1x over 2y, but remember, we're too lazy to write the 1, So it should just be x over 2y. So that's how I was taught in high school back then. It works up until it doesn't, okay? It works up until most students will make a mistake. I do prefer you practicing this side first before you start doing these shortcuts. So that means using the shortcut will help you to do, say, L. If we were to do L, negative 15z over negative 20z squared, the technique is you can write it like this. So students will say the negatives cancel out because double negatives is positive. So I got a positive answer. 15 and 20. 5 goes into 15 3 times, and 5 goes into 20 4 times. And then here, a lot of students would then say, well, there's one z on the top and two z's on the bottom because it's z squared. So cancel out one z, cancel out one z, and this is your final answer. So they would write it's positive 3 over 4 z. Okay? And that's the shortcut way of doing it, but really you can make a lot of mistakes, and I really prefer that you break it down first and learn that really well and get really good at it before you start doing what I just did over here. Okay? So I hope this video helps you. I know it's a bit of a long video, but that's what I mean. Division of terms is tricky. Continue to send me questions if you're finding this tricky to understand. Okay?